Hi there. This notes is going to be on absolute value inequalities. Now, a lot of students get stuck with absolute value, but if you understand what it really means, it's pretty simple. So absolute value is how far away you are from zero. So it's easiest to see on a number line. Here you can see a number line from negative 7 to 0 to positive 7. So this statement reads, the absolute value of x is less than 7, which means that we're looking for values of x that are less than 7 away from 0. So there's really two ways to think about this, the positive side and the negative side, because everything over here from 0 to 7 is less than 7 steps from 0. So x could be less than 7 on this side. All of these numbers here are less than 7 away from 0, like 6, 5, 4, 3, 2, 1. And these negative numbers are also less than 7 from 0. So like negative 5 is only 5 away from 0. So all of these also, when x is greater than negative 7, when x is greater than negative 7, so in order for a number to satisfy this equation, this inequality, x would have to be greater than negative 7 and less than positive 7. You could also write this as x is less than 7 and x is greater than negative 7. So x is greater than negative 7. So you could write this as a compound inequality. Whenever you have less than in the equation. So when we're using less than, or less than or equal to, that's going to give us an and inequality. So everything between negative 7 and positive 7, but not including those points because we don't have an equal to sign. So 7 isn't less than 7 steps away from 0, it's exactly 7 steps away from 0. Let's see what happens when you have a greater than sign. So here we're looking for all numbers that are greater than 7 away from 0. So 7 itself is 7 away from 0. That's not greater than 7, but everything on this side of the number line will be greater than 7. So like for example, 8 is greater than 7 because it's more than 7 steps away from 0. The absolute value of 8 is greater than 7. Similarly, on the negative side, any number that's over here, negative 7, negative 8, negative 9, that's greater than 7 away from 0. So you're going to have x is less than negative 7, or x is greater than positive 7. If you have a greater than sign or a greater than or equal to sign, you're going to have an or statement or an or inequality. So using this idea, we can see a couple of patterns. If you have less than, it's an and statement, and you're shading inside. If you have an or statement, it's, if you have a greater than sign, it's an or statement, and you're shading on the outside. Similarly, you can probably see that here, this stays the same, it just takes away the absolute value sign. And also, this one is the same but flipped. So the sign flips as well as the negative sign. Similarly here, you have x is less than negative 7, so both the sign and the negative sign flip. And here, everything stays the same. So you're really solving two things, the positive side and the negative side. Let's try it with a slightly more difficult example now. let's say you have the absolute value of 2x minus 3. Absolute value is less than or equal to 7. So since we have a less than or equal to sign, you're going to have an or inequality, an and inequality. And we're solving two different things. We're solving 2x minus 3 is less than or equal to 7, and the inverse of this one, this is switched and the sign is flipped. 2x minus 3 is greater than or equal to negative 7. Now it's just like any other equation or inequality when you want to isolate x. So you would add 3 to both sides in both cases. And you have 2x is less than or equal to 10. Here you have 2x is greater than or equal to negative 4. Divide by 2 to get x by itself. And you have two things to graph. X is less than or equal to 5, and x is greater than or equal to negative 2. So on your number line, this looks like a point at negative 2 that's solid, because it could be equal to negative 2, and a point at positive 5 that's solid, because it could be equal to 5, and everything in between. And if you test a point in between this area, you should see that it's an answer. See how 0 is a point in this area? If we plug in 0 here, we'll get 2 times 0, 0, minus 3. 3 becomes positive, and 3 is less than or equal to 7. So the solution set is anything between negative 2 and up to and including positive 5. So that's when you have a less than sign. Let's look at what happens when you have a greater than sign. The absolute value of x plus 4, absolute value, is greater than 5. In order to solve this problem, this is an or problem because of the greater than sign. So x plus 4 is greater than 5, or the opposite, x plus 4 is less than negative 5. Let's solve both of these. Subtract 4 from both sides because you want x by itself. And you'll have x is greater than 1, or x is less than negative 9. Since this is an or problem, when we draw our number line, it's going to be facing out. So let's see if that happens when we graph this. X is greater than 1. This is an open circle because it's not equal to 1. X is greater than would be to the right. Or x could be less than negative 9. So let's plug in a point and see if it works. If we plug in, let's say a 3. 3 plus 4 is 7. The absolute value of 7 is greater than 5. That is true. And let's plug in a negative 10. Negative 10 plus 4 would make negative 6. The absolute value of negative 6 is positive 6, and 6 is greater than 5. So it looks like this works. So our answers are x is greater than 1, or x is less than negative 9. And there's no compound inequality for this because it's not the overlap. We're looking at an or problem in this case. Okay, so try and use these to do the practice problems for your homework.